Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in introductory statistics. In less than 10 minutes, this video explains how to construct confidence intervals for proportions using the old school approach. Let's get started. When you're constructing confidence intervals on proportions, you're going to be making certain assumptions. The first thing you assume is that the sample is a simple random sample, meaning that any other sample of the same size from your population has the same chance of being selected. We're also going to assume that the conditions for the binomial distribution are satisfied. You may remember from the previous mini lectures where we talked about the binomial distribution. That distribution assumes there's a fixed number of trials. Each of the trials are independent. There's only two possible outcomes for each trial, and the probability of getting each of those outcomes remains constant for each trial. There are also at least 5 successes and 5 failures. This is an important assumption we need to check when constructing confidence intervals for estimating population proportions. Once we have these assumptions met, we can go ahead and express our confidence interval in different ways. Perhaps the most common way is with the format that you see here. So we're going to take our point estimate, which is our sample population, our sample proportion, and we're going to subtract the margin of error from it to get the lower limit for our CI, and we're going to add it to get the upper limit for our CI, using the equation for margin of error, which we looked at and examined in a previous mini lecture. Another way to express the confidence interval is with an ordered pair. So just like you would find an ordered pair for a data point on a Cartesian plane, where you've got an x and a y variable, here we're doing the same thing, only we're expressing it with the lower limit and an upper limit separated by a comma. We can also use the point estimate of the sample proportion, and we could list it as being plus or minus the margin of error. So here we don't need to add or subtract anything. We're just taking the center point and saying that the interval is this far apart from that center point of that point estimate. Common convention for dealing with confidence intervals is to round the limits to 3 significant digits. This is true not only of proportions, but also of confidence intervals for other population parameters. Let's take a look at some practice examples where we're practicing dealing with these formats. So express each given confidence interval below in the form p hat plus or minus e. So let's walk through this first example together. We have a confidence interval that goes from 0.25 to 0.75. So if we draw this out on a number line, and I find this is helpful because it helps to visualize what exactly is going on. So our interval is from 0.25 to 0.75. That means our point estimate is exactly in the middle of that interval or that range of values. So to get that value, I'm just going to average the upper and lower limits of my interval. This gives me 0.5, which is halfway in between 0.25 and 0.75. This means the margin of error is the distance from that center point, that point estimate, out to each edge of the interval. And to get that, I simply subtract the maximum minus the minimum, so I'm getting the range for the interval, and then I'm just dividing by 2. That gives me 0.25. So my margin of error in this example is 0.25. That means I can express the confidence interval in this format. 0.5 plus or minus 0.25. It's the same interval, just expressed in a different way. Okay, now I'm going to give you a chance to try this. So stop the video and see what you can do with this confidence interval, 0.412 to 0.908. See if you can express that in the form p hat plus or minus e. Then come back and we'll see how well you did. Okay, let's see how well you did with this. So if you start out by drawing a number line like we did previously, you're going to get something that looks like this. So our intervals from 0.412 to 0.908. The point estimate is the point directly in the middle of that interval. To find the value for that, I'm simply going to average my maximum and minimum for my interval. So the upper and lower limit for my interval, I average that out, get 0.66. That's going to be the point estimate there in the center. The margin of error is equidistant from the center out to the edge on each side of my interval. And so to get that value, I'm simply going to find the range for my interval and then divide by 2. This gives me 0.248. Therefore, I can express this confidence interval as 0.66 plus or minus 0.248. Let's review quickly the steps for going over a confidence interval. This is how we construct it. First, we're going to check to make sure our assumptions are satisfied. So the sample must be a simple random sample. The condition for the binomial distribution must be met. And we must have at least 5 successes and 5 failures. The reason why that's an assumption that we're making is because it allows us to use the normal distribution to approximate the distribution of sample proportions. Next, we find our critical values, the alpha over 2, that corresponds to the desired confidence level. We'll need this value to calculate our margin of error, which is the next step in constructing a confidence interval. Once we have the margin of error, then we simply add and subtract it from our point estimate, which is the sample proportion, and then we place them in the format for the confidence interval. We then round the resulting interval limits to 3 significant digits. That brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. We'll see you in the next video.